Hi, everyone. Welcome to the third episode of Litentry and Friends. My name is Jackie. I am the Director of Growth at Litentry. Um, yeah, I hope you guys have been doing great in this month since the last episode. I'm excited to see you all again. First of all, I would like to thank our community members. You guys are super, super supportive and has been giving us so much feedbacks for the Litentry and Friends series. We do want to keep it, last for a couple hundreds episode. And one of the feedback is that the first two episodes is not technical enough, and that's because the partnership with Konami and IME is more on the application level. But today, I guarantee you, we are bringing some high level, hardcore technical conversation here, and it's about privacy. So I encourage you to leave your question in the live chat session. Um, we will be answering them at the end of the panel. And welcome Alain, Brenzikofer, the co-founders of Integritee, and Fei Liu, the CTO at Litentry. For those who are not familiar with Alain, could you give us a brief intro about yourself and Integritee?
Yeah, sure. Thank you, Jackie, for having me here on the call. So I'm the co-founder and CTO of Integritee and also the head of decentralized systems at the department at supercomputing systems. And so with supercomputing systems, we have developed Substrate over the last 2 years. Started with a Web3 foundation grant and continued and gained the interest of the community. So we kept on, and we also founded a new company, which is Integritee, in order to launch a parachain so that we can offer a platform for third-party projects to launch side chains, to launch oracles, bridges, whatever they would like to build on trusted execution. And yeah, here we are.
Yeah, thank you. And Fei, could you give us a brief intro about yourself and Litentry?
Yeah, of course. So hi everyone, my name is Fei, and I'm in charge of the technical development and within Litentry. And as most of you may know, that Litentry is focused on decentralized identity, and then we specialize in aggregating identity data from different sources, from different blockchains. That is our focus. It's probably some of you know some other decentralized identity project. They are really focused on connecting online and offline data. That's not what we do. We really focus on the on-chain data. So that is what we see the real value lies. And then yeah, and happy to have the conversation with Alan. And then thanks for having me here, Jackie. And looking forward for the technical discussion here we have.
Yeah, okay. I'm very glad that for those of you who didn't know, both of our team has formed a partnership. So basically, the idea is that Litentry will build a T sidechain, so-called trusted executive environment sidechain using Integrity's framework to store identity linking information in a privacy preserving and secure manner. So speaking of trusted execution approach, could both of you give us a more detailed information and probably explanation of it? Like, what is it? Like, what does it do? Alain?
Who goes first?
Okay. It's a 3D conversation.
Yeah. Okay. So trusted execution, to put it very simply, offers us the possibility to isolate a process from the system administrator. Because now with the machines that we use, we are very accustomed to the fact that whoever is the administrator on that system can see the entire memory contents, can start and shut down whatever processes, and can also change programs without kind of someone outside of that machine noticing it. And what trusted execution environments are, they are a hardware guarantee where the CPU manufacturer has a design that allows processes to run on encrypted memory, and the manufacturer, in our case, it is Intel. So Intel SGX is the technology that we're applying. Intel can also remotely attest that I am actually executing something on a genuine SGX machine. And not only that, but also that the code which is executed, the binary has a certain hash. So that means, let's assume you have source code on GitHub. You can build that source code deterministically. You get a binary, you take the checksum of that binary, and you execute that on an SGX machine. Then Intel can remotely verify that this is indeed the binary which is executed. And the system administrator has the power to shut the process down, but it doesn't have the power to modify the process in any way or to see the memory. And now if you have any kind of service running inside such an enclave, you can, from the outside, talk to that service through TLS, so kind of SSL encryption and authentication. And you know that your data will be processed as defined and without the operator of the machine seeing the data.
Yeah, I mean, Alain really jumped in with all the hardcore technical details. I really enjoyed this. I do think that with me adding some information on the application side, and it can really give the user a good insight on the things. So, for example, as for us as a protocol, dealing with sensitive information, specifically connected to the person's identity, and then we want a solution that can really give us guarantee that the information or the calculation or any kind of interaction with this data is run in a secure environment. And then, as you know, this with current cloud structure and everything is, the machines, the VMs all run virtually on the cloud, and that's now controlled by us. And then we don't know what's happening. Of course, we get the term of services, agreement, but we won't go through it. We don't know what, we don't have guarantee. So and then so it's very natural for us, to look for alternatives, and then for example, to solve this privacy issues, to do the kind of data transactions and without revealing information. So by looking at this, and then we check the cryptography primitives, such as the zero knowledge proofs, and also and another lane actually falls in what Alain's doing. This is a trust execution environment, and then this really gives us the guarantee that we know that our program is run within a trusted environment. And then that's, the good thing is that attestation process can also be, integrated. That means that, if we want to make sure, and then we can make sure. So this is something that's a really good, like a guarantee by the design, and something can be run within in a secure environment. So so I hope giving this application side of a story can really complete some of the missing dots, for the audience.
Yeah, so speaking of like trusted execution approach, I'm curious, like there are so many privacy solutions out there in the market, like for example, zero knowledge proof, and you also have multi-party computation, MPC. I'm just curious, like, how does trusted environment approach compare to these two privacy solutions with respect to SSI, which stands for self-sovereign identity?
Yeah, so there are really many ways how we can approach this privacy issue, and you mentioned the prominent ones, I think. Now, maybe we should talk about the trust assumption first. If you have zero knowledge proof, that means you trust you trust no one outside your machine where you actually compute your zero knowledge proof. So you still have to trust the machine that you use to work on, because if there's a backdoor there, your data can leak anyway. But you're not trusting anyone outside of that boundary. But you are trusting in very cutting edge math. And this is really still a hot research topic, and zero knowledge proofs are still very academic. So they can be, they have shown to work well with very simple problems like Zcash, for example, where you just transfer tokens, but they don't generalize really well. You don't have kind of all these, very good libraries available that can let you solve whatever you like to do with zero knowledge proof. So you still need experts to design this stuff. It's a bit similar with multi-party computation. That's where you just say you have a group of operators that compute, for example, the links between credentials, or just compute on private data in general. There you just say you don't trust a single machine which operates on your private data. You just trust that the majority of the machines, let's say you have 5 different machines, you trust that the majority is honest and doesn't disclose your data. And now every one of these machines only gets a fraction of the data, and only if they compute something together, only then can the computations really take place. This also is a very, well, it's not so new as a technology. It's been around for a while, but still it's not so easy to apply this tech for general computation. So it's zero knowledge proofs and multi-party computation. They have also the drawback that they give you privacy at the cost of scalability. So zero knowledge proofs are heavy to compute and quite big payloads to put on chain, and multi-party computation comes with a very big communication overhead. Now, trusted execution also makes compromises in a certain sense. You have to trust the manufacturer of the machine, of the trusted execution environment, and you have to trust the manufacturer's design, so that the hardware, the CPU, is really designed in a way that it doesn't show vulnerabilities. And you also trust the manufacturer for remote attestation. So you also trust that attestation service not to attest fake devices. And I think this is how these approaches compare. The advantage of trusted execution that I see is that you can easily develop custom business logic with just your preferred language, programming language. You don't need to go to dig deep in the math of the protection that you're enjoying. You just, I mean, in our case, it's Rust code, and you just go ahead with that and implement whatever you like.
Yeah, that is a very good point. So I just want to expand a little bit on the zero knowledge proof. What Alain said about different security primitives. it's really about what you trust and in the level of your security. I mean in the blockchain world, this is something very famous called garbage in, garbage out. Which is if it's something that input is already bad, and then which you cannot guarantee, and then that is already something of a bad start. So that's what I see really. Once I have a way of knowing that my hardware or my data is running in a secure environment, I basically, as Alain said, I can really do whatever programming I normally do. I just got the machine, got the CPU, got the memory, got the disk, and then I just program as I have always been, and then that's open up, of course, the possibilities. It's not open up the possibility. They just like offer the same possibility that I can do on the normal machine, but with a guarantee, of course, that my program is running really, securely, and then nobody can tamper with my program and then giving wrong results. And then that's the first thing. Second thing, I do think. I do think they are addressing different issues. With this, of course, when we're talking about privacy, this is a rather big topic, and then and then zero knowledge proof definitely has its position in solving some of the problems, but it's really not something that we're aiming for. What we are aiming for is really like we want to have something to be able to integrate into a substrate system, and then to be able to integrate our stack, and our software really easily, as a sidechain, for example, and then that's something really valuable. And then Substrate TE project, from Web3 has got funded from Web3, has really done a terrific job on making this kind of progress on this direction. So we don't need to reinvent the wheel. We can just take this setup and then apply it, and that's what I see is really that the biggest advantage that we see from the whole Substrate and the Integritee technical stack.
Great. I guess I can jump in, and I've got questions from the chat sections from Slawomir, who asked, how does it compare to off-chain computation based on game theory in economic incentive verify like TrueBit? Because it's kind of related to the questions that the topics we are discussing. So I guess you guys can just answer these questions.
To be honest, I'm not familiar with TrueBit. It's so. So I guess I cannot in depth answer that.
Yeah, I mean that is that I don't. I mean, like Alain said, I don't know TrueBit, but I can dissect the other part of in this question, that using economic incentives actually to make some guarantees. I mean, make incentives. It's a double sword. It's a double-edged sword. So from my view, I mean, as a protocol, when we are talking about identity protocol, and then we want to be on the safe side. We want to be always on the safe side, like saying, okay, from the technical level, do we have some guarantees? Do we have something that we can make sure of something running really securely, and without other people tampering? And then there's a way that we can prove it. And this is really our, like the question we want to be answered. And of course, using economic incentives is one way to go, but that's not the only way to go, and that's not for our eyes the ideal way to go. So this is the thing I see. But TrueBit, I don't know, and then we definitely worth looking at it. But in general, I think we are looking for a technical solution that, and also as TE, it's kind of industry standard. So it's very natural actually to jump on that wagon,
And there's, so just having a very quick look at it, incentivization of privacy is kind of tricky because how do you prove that you haven't leaked something? So you can prove integrity with, and you can incentivize integrity and punish if something is done in a bad way.
Yeah.
But you cannot have a game theoretic incentive to keep something private. That just doesn't
it's hard,
really.
It's hard to imagine. It's if it's something can be incentivized, it's something need to be verifiable. Yeah. And something that I have leaked these things, and just hard to verify. I mean, it just like prove something. Yeah, that is indeed a challenge. So, but as I said, we are really looking for a technical solution, and then that's why actually we have chosen the TE to explore further on TE.
Yeah, got it. Very, very informative, and thank you all for sharing your thoughts on the topics. And the second topic is that how does T reduce linkability risk of SSI's credentials?
Do you want to go first, Fei, or or should I?
Yeah, Jackie, can you further expand on the question? I don't think I fully grasp the question.
How does T reduce the linkability risk of SSI's credentials?
Yes. Okay. So so in general, is that on blockchain things are pseudo anonymous, and then if as a user you avoid the step of exposing your linkage to your real identity, and then you remain private. And then Litentry, one of the things that we focus is that we aggregate your information on chain. That means we first need to have your chains, your identity as an aggregation. That means we know that you are on different. Sorry, the protocol knows that you are on your address on different chains, and then this information is crucial. This information is like essential for everything, and then this part has to be kept private. This is really like when we're talking about privacy part, and this is something that we're talking in specific. And then so that is what however, as you can imagine, when your on-chain data being leveraged, and then this information will be used to derive additional informations, and then this process we want to encapsulate this process within the TE environment, and then the TE will be responsible initiating that dissect this connection, and then do further actions on these things.
Yeah, maybe I can add. Maybe we try to make a concrete example. So if you, let's say you have all your savings on the Ethereum blockchain, and you are a very active participant on Subsocial in the Polkadot ecosystem, and you might share some private information on Subsocial, which is linked to your Subsocial or maybe Polkadot account, and now for some reason maybe you want to participate in some kind of a I don't know, lock drop or something. So you would have to link your Ethereum account with your Polkadot account, and now comes the privacy issue, because you're linking accounts, and you have disclosed different sets of information on both chains. And now if you link the accounts, the entire information now is linkable to you. So the ones that are following you on Subsocial, now they know how many ETH you hold. And I mean, pseudonymity helps you in a way, but well, usually you're not taking that really diligent care of separating your accounts and your actions such that they cannot be linked. And this is now where I think trusted execution can help, because you don't need to link these accounts on chain in a smart contract or in a pallet or whatever. You can link them off chain and just commit a proof. So let's go back to that lock drop example. You can just reduce the account information on the fact that you have locked a certain amount of ETH and just commit that proof to the Polkadot side, for example, where some project might give you tokens in return for a lock drop. And this is how I see that we can separate the linking and kind of the insight that the data gives us, and really just prove exactly the information that needs to be proven and disclose nothing more than that.
Yeah, that's a good example. But as I said, we introduced trust. Substrate is really to solve this linking, to really shield this account linking data.
Well, something that I'd like to add here is that, I mean, you could just use SGX in the cloud somewhere for that purpose. But the problem is that we actually want to convince individuals who want to use Litentry of the remote attestation. And that is actually where our framework comes in, because, well, we didn't invent SGX. it was there already. You can rent it in the cloud. There is already remote attestation, but you need a commercial license with Intel in order to get that remote attestation. And individuals will not have such a license. So we actually verify that attestation report on chain, and therefore it is public information what services or what servers are executing a specific code, and that is how blockchain and trusted execution comes together. I mean, we also envision to go in the direction of open source TE hardware, where the blockchain might be the single source of remote attestation. So we would use the blockchain itself actually as a registry of devices that have gone through a provisioning process at the fab, which again needs trust in the manufacturer, but only on the design of the silicon.
But Alan, I want to expand on this topic. You know, when you talk about the yeah, so we have to eventually trust somebody. So that is okay. And then so when you're talking about this attestation, remote attestation, I don't think I fully understand that. So currently that it's you need to, like you said, you need to have a commercial license which is registered with Intel, and then so of course we trust Intel, and then Intel can only the one that offer this attestation process, and then as of the device ID running on what software, and then this check. And then if you are putting on the blockchain, and then this is also like revealing the information on the device, no? I mean, it's not like we can just simply put this information out. And am I understanding this correctly? So because device ID is also identifiers. So I can imagine they don't want this thing to be public.
Well, in our case, with the Integritee approach, we don't care about the privacy of the entity which operates the machines. To the contrary, we want to hold them accountable. Well, at least accountable for availability. I mean, we trust on the technology, but we wouldn't care so much if they are identifiable. We care about the privacy of the users of what they are operating. But still, we do use unlinkable attestation. So that means Intel has two approaches to this. One where you can have your device identifiable, and one where it is unlinkable. But I think this shouldn't be a concern, because if you run an SGX machine, yeah, that's so be it. So yeah. if your device can be linked between two different requests, I don't think that is a problem for our trust model.
Yeah. Awesome. Jackie, if I can inject one of my questions here, that would be awesome. Would that be okay?
Yeah.
Okay, awesome. So I do know, you mentioned this SGX, this thing is built by Intel, and then so that means it's bound into one architecture, and then so ARM also has something similar. Does it?
Yeah. Yeah.
Okay.
They have trust zone. Yeah.
I see. And then, so as of maturity, and then do you have a kind of a comparison between these two?
Well, I think the main comparison there are also other technologies. I mean, I think all big cloud providers are now working on TE solutions, some on their own and some built on something on kind of either ARM Trust Zone or Intel SGX usually. ARM Trust Zone is built for a different purpose than what we are using. ARM Trust Zone is an IP core that you can use to convince the owner of the device where Trust Zone is on, kind of your mobile phone, to convince the owner of the device that, for example, the fingerprint scanner is directly hooked to a private to an enclave to make sure that it's really hard to hack the fingerprint sensor. But they do not offer remote attestation. So I cannot convince you that my phone has a trusted execution environment on it. With Intel SGX, I can convince you that the machine that I am running is an SGX machine executing a certain
with the assumption that we trust Intel, we trust that.
Yes, absolutely. And I mean, no one says there cannot be a remote attestation for ARM Trust Zone. There could be, and we have tried it actually. We have played around with that technology, but you would need ARM just supplies the IP core, and that goes into a silicon from, be it NXP or some hardware provider, manufacturer, and they would need to burn fuses and to register remote attestation primitives on our blockchain, for example, and then you could remotely attest trust zone devices as well.
Yeah, awesome. Thanks for answering the question.
Yeah, got it. So as you guys have mentioned, you have this Intel SGX. Like Microsoft is really strong in this privacy computing space. They have this Intel SGX based, a confidential computing virtual machine called Azure. So the next topic is that why don't we just use them, these virtual machines? What benefits this Integritee approach can offer?
Yeah. So if you go to Azure to rent your trusted execution machine, then you not only trust Intel, but you trust Azure as well. And that is, I mean, there are settings where this is interesting. I mean, if you have, if you as a company just want to deploy something to the cloud and you want to be sure that it runs on SGX, okay, you can do that, but you still trust Azure because you don't directly get a quote or a report from Intel, you get it from Azure. So Azure is kind of in this PKI system. Intel is the root authority, but you actually get a signature from Azure. And this is not useful if you want to convince the user of your service. So, and that's where the blockchain comes in. The blockchain can verify the certificates from Intel attestation services directly and only register enclaves which have passed that test. And then it is public information. Then in this blockchain, you can look up all the devices that are available with their URL and with their latest remote attestation and with the hash of the binary which is executed. So you know, without having an account with Azure or without having a license with Intel, you can be sure that remote attestation has passed.
Yeah.
So it's we call this just public auditability, and that's what you don't get from the from cloud providers.
Got it. Fei, do you have anything to add on to this?
Yeah, no, I think what Alain says is exactly correct. I mean, as it comes down to the bottom, I mean, just like to answer the question, how much you trust. I mean, to what extent your trust is built on. And of course, we want to be as near as the root possible. You know, we trust the root certificate, which is from Intel. I mean, that is pretty much the only thing we trust. And then the rest we can just verify for our own, rather than just trust against some intermediaries. You know, that is something that we just want to avoid. From this stage, it makes total sense, I think.
Okay. Yeah. Yeah, thank you so much for answering these topics, and yeah, the discussion is very informative. So we have a few questions from the audience as well. The first one is that Microsoft is entering the DID space. How does it affect Litentry? From Mohan? I guess Fei could answer this question.
Oh my God. Yeah, so the things, I think Microsoft has been in the DID for many years. I mean, it's not really. I mean, their project is I mean, if I remember correctly, they are in this in probably 2018, but they didn't get really anywhere. And then, as I said, Microsoft focus is like it's not the same with us. You know, what we're building is we are building. We are building on the premise of Web3. That is not what the Microsoft is doing. We are giving the user the control back. That's not what Microsoft is doing. So, and then as far as I know, there's a DID. There are already some specification. This is really, for example, I can give you an example that to test whether the driver's license is authentic. This is something like a more the connecting the off chain, and then plus working with the authorities to provide verification mechanism for this identity to be valid. And then there are already the draft kind of specification available, and then there are other projects building on top of it. And I think this is also what Microsoft DID program is doing. Although I'm not from Microsoft, don't quote me on this. But as I said, they are focusing on different things. We are building on the premises of Web3.
I think this is really important. What you, your last sentence is the point.
Yeah.
I mean, do
exactly.
we really want a private company to be in charge of identity? Well, I certainly don't.
Yeah. That's the things, we want to make these things open. I mean, if Microsoft can make these things open, it's also possible, but that is the, we don't want to go to the detail of the whole private companies, I mean, how much they can give up, with their data, which is they deem as a most important asset. And of course, I mean, Facebook is building in the currency part, they want to tap into that market. Microsoft want to tap in the identity market. Is fine. I mean, but I don't think they fall under the Web3 umbrella.
Yeah. So having a private company in charge for identities fundamentally, conflicting with, the blockchain native concept.
Yeah, but that's, people can argue that we are also, Litentry is also a private company, which is not necessarily true. But I mean, again, I don't want to jump into a monologue, but if anybody knows is that how crypto projects is get founded, it's really like, we test our idea, we build our solution, and then eventually we give back to the token holders. And then that's what drives the value of the lead tokens. And we don't have any incentives actually to really expose user information, because that's like breaking our own protocol. That just not how it will work. And I think from this perspective, we are really incentivized to build a solid solution, a solid product.
I think there is one very beautiful thing about this decentralized approach, how Litentry is following it. It's not only about kind of private companies. It's also about, so it's not necessarily better if the state does it. So it's and I'm talking about kind of the IT infrastructure, which can always be hacked. So if it is a private company managing your identity information, then that identity information nowadays just resides in some database, which is protected by basically a firewall. And sooner or later, the data will leak. We see this every day. The same applies to the state. So the state also keeps that data in a database, and that database will leak sooner or later. But with kind of the trust over IP approach, where you have yourself in charge for disclosing data just based on each occasion, and then have the linkability in kind of off-chain trusted execution way, then there is no database which holds all the information that can be hacked. Then the data really resides in a decentralized network. There is no one who has access to all this data, and this is, well, we call this privacy by design. It's just you structure the architecture such that there is no single point, no single honeypot or whatever where data can leak. And I mean, there are vulnerabilities with all the solutions, okay? But we're just putting the bars higher and higher. So more obstacles and to see less leaks.
Yeah, that's a good point.
Yeah, got it. So here comes our last questions of this panel discussion. From the Woken, how expensive are the long-term implications of this technology, and are you able to give perhaps real use cases? I think that can be combined with the questions from Attilia. How long does it take to make this happen?
This is a hard question to answer. And then, a Substrate is rather, okay, let's probably start at the bottom. Intel SGX is rather mature. and then rather tested, and then major service provide major cloud service provide service to it, and then this is quite popular. And then so Substrate is has been building within the last 2 years. Is also relative mature things. And then currently we are really in close collaborations and working on our design, integrating the solution from Substrate. And then as of being, I'm not sure how to understand expensive, but so first the user owns his data, and then depends on the use cases. For example, that a lending platform like Aave, want to know your credit history, and then this information will be relayed from Litentry network, and then user from Litentry network will have the possibility to either approve or disapprove this request of accessing your data. Be rest assured that data will not be your full financial history. It only will be, it will only be, you can imagine, like true and false. The question will be very specific, and then the answer will be also like a rather very indicative. And then so this is one of the use case. And then as of expensive, of course, this elite token is built within every step of the process, and then it won't be I can't really say how expensive it will be, because that really depends on the kind of how much you use the network to calculate, and then but it will be calculated in lead. Of course, it's to our interest to make those things as cheap as possible, as affordable as possible.
Yeah, maybe so if we talk about maturity, so the Substrate framework, which now we call it Integritee now, so it's the rebranded framework, has been in field testing since a year. So we have a testnet already with TE off-chain workers. Still, I mean, we should be careful in terms of calling it mature. I mean, I'm well aware that there is still a lot of work in front of us, but you can already use the platform for very specific use cases like the one with Litentry. So and I think this example with credit history shows how complex such a query can be. And I mean, for example, you might want to disclose that you have always paid your bills, or kind of not have had any whatever negative history, but you might also have to disclose your family situation. So you have to prove maybe that you have 2 kids aged from such and such. And in the end, it is the combination of all these queries which could be encapsulated, and a single Boolean comes out of it and says, yes, this person qualifies for your requirements, and then not a lot of data has leaked, because it's really just if the query is generic enough, then there is not a lot of information that leaks, and that's why it is also important to know the query which will be running, obviously. But I'm drifting away. So if the question also was, where are we heading to in the long term? I really believe that this combination of blockchain and trusted execution can boost the adoption of trusted execution and blockchain into, let's say, the everyday enterprise sector that we have now, which are still very reluctant to adopt blockchain. And I think there is more and more the need for privacy tech. So I see really big potential, even in the space of the not so crypto native companies. And in terms of tech, I mean, the vision for me is clearly that we go to open source hardware. So I mean, it's kind of Intel SGX is just the tool that we have at our disposal today, which is, I would say, it's production ready, and there are vulnerabilities which are discovered by academia, but they usually get patched very quickly by Intel, and yeah, there's that. So open source hardware, be it Keystone or something in that direction, is where we would like to see things going.
Okay, so lastly, I would like to know your vision or any expectation of this partnership to end this panel discussion. I guess we can start from Alain.
Well, I believe that this partnership makes a lot of sense. It's just there is this technology, the framework, and Litentry really has a use case which can leverage this technology to its full potential. And in that sense, I hope we will be working together in the long run for a long time.
Yeah, thanks, Alan, for the kind word. Yeah, I mean, likewise, we believe in the future of cryptocurrency. We believe in Web3. We believe in the person should have control over his or her own data, and then to be honest, we share the vision, with Alan when it comes to the TEE, the whole landscape. We share the vision. And so with that in mind, of course, we're gonna tap in. We're gonna just get Alan's resource as early as possible, and then we are really in a deep connection, when it comes to the cooperations. So yeah, we are very happy actually to get to know Alan and then the whole team, and then and further build on top of Integritee, and then. I think it's bright future, as of our collaborations.
Great. Yeah, that's the end of our panel discussion today. Thank you so much for joining. I'm sure the discussion tonight is very constructive and meaningful. I wish the partnership all the best, and I truly believe we can achieve something really remarkable and distinct. So thank you so much, Alain. Thank you so much, Fei. Thank you so much for all the audience. I'll see you next time. Bye.
Ciao, ciao. I mean, thanks, Alan.
Thank
Thanks,
you.
Jackie.